Okay, for problem number 4, given the assembly as shown in the as shown of steel and aluminum solid shaft. So given po yung figure natin na may aluminum and steel shaft. The question are the ratio of the torque of steel to that of the aluminum. TS over TA is most nearly equal to. Then the second question is torsional shearing stress in the aluminum in MPa is most nearly equal to. Then torsional shearing stress in steel in MPa is most nearly equal to. Then for the fourth question, the maximum angle of twist in the system in degrees is most likely equal to. So meron tayong uh, solid shaft na uh, composed of aluminum and steel and magkakaroon ka ng torque which is 1.25 kilonewton meter. Then kapag tayo nag-analyze nito, we all know that yung inikot nung isang material dito, kung halimbawa inikot mo yung steel, so the angle of twist ng steel is the same dun sa angle of twist ng aluminum natin, no? Pareho lang siya nung angle na mapoproduce based dun sa pag-ikot base dun sa torque na in-apply natin. So let's have this solution. Solution number 4. So angle of twist for aluminum is equivalent kay angle of twist for steel. And angle of twist is equivalent kay TL over JG. T is the torsional force na nag-act dun sa material. Yung L is the length of the material, J is the polar moment of inertia of the material, and G is the modulus of rigidity ng materials natin. So let's say that TL over JG, this will be for aluminum, is equivalent kay TL over JG for steel. So, therefore, TA times yung length ng A, ang length ng A ay 3 meters, ito, 3 meters to, all over JG. Take note that J is the polar moment of inertia, and when we talk about polar moment of inertia of a circle, so meron tayong formula na pi d to the 4th over 32. Make sure na natatandaan nyo yung polar moment of inertia formula na yan. No? So we have here pi times d, which is 75 mm, raised to 4 all over 32 multiplied by the g, which is 28 GPa, equals torsional force acting on the steel multiplied by the length of steel, which is 1.75, divided by pi times the diameter of steel, which is 50 mm, raised to the fourth all over 32 times uh, 83 GPa. Ang pinapahanap dun sa problem kanina is si TS over TA. So, si TS over TA. Therefore, ilipat ko doon. Tapos ito, ililipat ko doon sa ilalim. Ito, ililipat ko doon. No? Tapos yung TA, ililipat ko doon sa kabila. So, lagyan na lang natin sa calculator. We have here 3. Ito, 3 multiplied by nito, polar moment of inertia, which is pi times 50 raised to 4 over 32 times 83 divided by ito naman, tapos itong 1.75 multiplied by nitong pi times 75 squared raised to the 4th all over 32 multiplied by 28 multiplied by 28 equals. So meron tayong 1.003779,289. So let's say that it is 1.0 na, no? Makita rin ng 003 eh. So TS over TA is equivalent kay 1.0. So this will be the answer for number 1 question. Then we all know that the torsional force acting on aluminum plus the torsional force acting on steel is equivalent dun sa total force, total torsional force natin. So we can see that T S is equivalent kay T TS TA plus TS pala. TA torsional force in acting on aluminum plus torsional force acting on steel is equivalent dun sa total force torsional force which is 1.25 kilo Newton, no? And we all know that the value of TA is equivalent kay TS. So let's say that 2TA is equivalent kay 1.25. Therefore, TA is equivalent kay TS is equivalent kay 1.25 divided by 2 is equivalent kay 0. Kilonewton meter. 0.625 kilonewton meter. Okay? Then, so pinapahanap dun sa atin is the torsional shearing stress in the aluminum and torsional shearing stress acting on steel. No? So we have here torsional stress. Stress is equivalent kay T R over J. So torsional stress is equivalent kay T R over J. Hindi ko sure kung ano ang no, ganito ata 'yan. Hanapin nyo na lang basta torsional stress, no? So, TR over J. So, si T ng ano natin, ng aluminum. So, let's say that aluminum ito. So, stress at aluminum is equivalent kay T, which is 625 Newton meter. Newton meter na po ito. Multiplied by the radius which is equivalent kay ito. Radius nitong 75 which is 32.5 mm divided by the J nung which is ito. No? So pi times 75 square raised to the fourth all over 32. Torsional stress at aluminum is equivalent kay, lagi ko na lang sa calculator, no? So we have here 625. Make sure na yung unit natin is pare-pareho. Since ito ay naka-Newton meter, ito ay naka-mm, ito ay naka-mm to the fourth, so dapat ito ay naka-mm din, no? So ito kasi, itong 0.625 is kilonewton meter. In-convert ko pa lang siya into Newton meter. Newton meter nga. So magmo-multiply pa tayo ng 1,000 dyan para tanggal natin yung meter at maging mm po yung sa equation natin. Times 32.5 divided by pi times 75 raised to the fourth divided by 32 equals. So we have here stress at aluminum, torsional stress at aluminum is 6.54 MPa. So this will be the answer for number 2 question. And for number 3 question, same lang din po siya. So TS torsional stress at steel is equivalent kay 625 times 1,000 times 25 which is the radius divided by pi times 50 raised to 4 over 32. So torsional stress at steel is equivalent kay 625 times 1,000 times 25 divided by pi times 50 the fourth divided by 32. So, meron kang 25.46 25.463 4647 MPa. So this will be the answer for question number 3. For the last question, the maximum angle of twist in the system in degrees, no? So ilalagay niyo lang ulit itong value na to dun sa ilalagay niyo lang yung mga values na to dun sa formula natin to, no? So angle of twist for A is equivalent kay TL over JG. So pwede kong sabihin 6.54 multiplied by L, which is equivalent kay 3 meters. So 3,000 na to. Divided by JG. Wait lang. Wait. Ito pala ay 625 pala. 625 times 1,000. Erase ko lang. Hindi na kasi mag-cash siya. Angle of A is equivalent kay TL over JG. Therefore, angle of A is equivalent kay torsional force 625 times 1,000 para maging Newton mm multiplied by length. Ang length natin ay 3,000 mm all over JG pi times 75 raised to the fourth all over 32 multiplied by 28. So, lagyan nyo lang natin dyan. 625 times 1,000 times 1,000 times 3,000 divided by pi times 75 to the fourth over 32 multiplied by 28 equals. So, meron tayong 21. Wait. Check natin yung mga unit pala. Si 28 is naka-GPa, no? So, kailangan natin siyang MPa. So, ito ay times 1,000 din. Multiplied by 1,000. Equals. So, meron tayong 0.0215556, no? So, meron tayong 0.2156 na angle of twist, but this angle is in radian form, no? Ang hinahanap dun sa problem natin is naka-degree. So, i-convert mo lang ito into degree, no? So, naka-rad to. So, 2 pi is equivalent kay 360 degrees. Therefore, hindi na magkasya dun sa board natin. Answer, multiplied by 360 divided by 2 pi equals divide 2 pi. 1.23 degrees. 1.235 degrees. Therefore, this will be the answer for the last question. Okay? So, yan. I hope na nagigets nyo na. So, let's proceed to the next problem. Okay, problem number 5. Problem number 5 ay from the figure of a beam below supported by two identical springs with the following properties. N is equivalent kay 20 turns, D is equivalent kay 10 mm, and capital D is equivalent kay 150 mm. The question is the ratio of the force exerted by spring C to spring B PC over PB is most nearly equal to, then assuming the light spring, the maximum shear stress in the spring is most nearly equal to, then the third question is the minimum shearing stress in the spring is most nearly equal to. No? Okay. Wait lang ah. Okay, para dun sa ulit sa aking mga estudyante na sa correlation, I want that Miss Abella, Fadriquela, Mr. Lim, and Miss Makula to comment the torsional force formula on this video. No? Okay. Okay. So, ito yung ano natin. Meron daw sabi dun sa problem. Meron dun sa problem natin na dalawang spring na nagsusupport dun sa ating beam, no? Na may load na 30 kilogram dun sa end part ng beam natin. So, syempre kapag nag-apply ka ng load na 30 kilogram dito, tendency niyan is mag-adjust dito ito at bababa tong pareho, no? Then, yung pababa nito is syempre varying din yung ano natin. So, para magkakaroon ka ng another triangle ulit dito dun sa reaction ng 30 kilogram force natin. So, kumbaga para magkakaroon ng broken line pa ganon, magkakaroon ka ng triangle, no? Then, take note that the formula for our spring is equivalent kay yung stress at spring is equivalent kay 64, wait lang, sulat na lang natin. Solution number 5. Stress at spring, wait. Take note natin ha. Stress at spring is equivalent kay 64 PR to the third n over g d to the fourth. Okay? So 64 P is the force, R is the radius, N is the ratio of modular elasticity, given naman yung N, yung number of turns. Then yung G is the modulus of rigidity ulit. Then yung D is given ulit din sa problem. No? So, yun. So, ano natin siya, i-ratio and proportion natin kasi sabi ko kanina, the reaction will be pag ganito. Pag nag-apply ka ng loads na 30 kN, magkakaroon ka ng triangle dyan. So, this will be the elongation for B and elongation for C. Elongation pala na, hindi pala elongation. So, for the elongation, ratio and proportion lang natin siya para makakuha tayo ng value. Elongation for B, all over, since similar triangle tayo, ulit. Elongation for B, the height of this, tapos yung distance which is 1.75 equals elongation kay C all over 1.75 plus 1.75. So, 1.75 plus 1.75 is equivalent kay 1.75 times 2 para sigurado tayo calculate natin. Meron tayong 3.5. Okay? So, yan na yung magiging ano natin. Tapos, ilalagay na lang natin yung mga values. Okay? So, let's say that pinapahanap ay force daw PC over PB. So, let's say that ito is 64 PR cube N all over G D to the fourth multiplied by 3.5 equals 64 PR cube N all over G D to the fourth times 1.75. Ito ay para kay C, ito ay para kay B. Take note ha, GD po to ha. Baka kasi makita nyo 60, parang 6 din. Okay? So, 64, lagay ko ulit, 64 P B times yung R natin, R cube. So, since pareho naman ang R yan, no? Pareho ang R, pareho ang D, ito. So, pwede na natin cancelahin yung mga, hindi, pare-pareho naman ang value. So, ito ay cancel yung D, cancel yung D, yung R, cancel din yung R, yung N, cancel din, kasi pareho lang ng value. Yung G is pareho lang din, so pwede na natin itong cancelin, at ito, cancelin. Okay? So, check natin. So, matitira na lang ay 64 P B times 3.5 is equivalent kay 64 P C times 1.75. Ang pinapahanap ay si PC over PB. PC over PB is equivalent kay, ito, ilipat ko dun sa ilalim nito. So, lagyan natin sa calculator. Actually, yung 64 pwede na nating tanggalin dyan eh. Pero ilagay ko lang natin 64 times 3.5 divided by 64 multiplied by 1.75. The answer will be 2. So, PC over PB is equivalent kay 2.0. Okay? This will be the answer for question number 1. Then, question number 2, ang pinapahanap po ay assuming light spring, the maximum shear stress in the spring is most nearly equal to. So, tendency natin is mag-moment tayo dito para ma-compute natin yung mga values na nandito. No? So, let's say, summation moment at, wait lang, summation moment at A is equivalent kay 0. Clockwise is equivalent kay counter. So, the clockwise is 30 kg. Then, yung counter natin is ito. Siyempre, magkakaroon ng reaction dito pa ganun at magkakaroon ng reaction dito pa taas. Okay? So, lalagyan natin P, B multiplied by perpendicular distance 1.75 plus PC multiplied by perpendicular distance 3.5 equals 30 kilogram multiplied by 1.75 times 3. Therefore, meron kang 5.25 na distance. 5.25 distance. Okay? Then, lagay-lagay mo na lang yung value. Ito, ilagay ko dito para ma-compute mo. So, meron ka ng PC at meron ka ng PB. Okay? Lagyan natin yung value sa calculator. So, ang pinapahanap ay si PB muna. PC muna tayo. So, lalabas, ito ay, kung PC ang pinapahanap, so si PB is equivalent kay 0.5 ng PC. So, 0.5, ito, 0.5 ng PB is equivalent kay 0.5 ng PC times 1.75 plus 3.5. Wait lang. Tapos, sa taas ay 30 times 5.25 equals 3.6. So, PC is equivalent kay 3.6 kilogram multiplied by 9.81 para maging Newton times 9.81. So, the answer will be 35.316 Newton. Ay, mali. 30 pala to. Wait lang. 30. So, lalabas 36 to. Wait lang ah. Tapos tayo magiging 353.16 kilonewton equals. So, 353.16 Newton. Then, yung PB, yung value ni PB naman, therefore, meron tayong 30 times 5.25 divided by 2 times 3.5 plus 1.75 times 9.81 na. Para tuloy-tuloy. Equals. So, the answer for PB is 176.58. 176.58 Newton. So, meron na tayong value for PC and PB. Then, ilalagay na lang natin siya doon sa ating formula for stress. Okay. Max stress is equivalent kay, may formula ulit tayo for max stress which is 16 PR all over pi d cube multiplied by 1 plus d over 4r. Okay. So, ilagay nyo lang yung value. Meron kang P, meron ka ng R. Yung R ay given dun sa ano natin. So, ilagay mo lang dyan yung 150 divide 2. Tapos yung D na given din kanina na 10 mm. Tapos yung R ulit, pareho lang naman. So, let's say that pag-usapan natin yung stress dun kay C. Stress dun kay C is equivalent kay 16. Force kay CI equivalent kay 353.16 multiplied by the radius. Ang radius natin ay 75 mm kasi nga 150 yung D natin. Divided by pi times 10 cube multiplied by 1 plus D which is 10 all over 4 times 75. So, ito ay stress kay C. Tapos, stress kay B is ganun lang din. 16 times 176.58 times 75 divided by pi times 10 cube multiplied by 1 plus 10 all over 4 times 75. So, ilagay lang natin. Meron tayong stress kay C at stress kay B. Lagay ko muna. Okay, lagyan natin sa calculator para so we have here 16 multiplied by 353.16 times 75 divided by pi times 10 cube multiplied by 1 plus 10 over 4 times 75. Okay, so stress at C is 139.3937 MPa. Since ang mga unit natin ay Newton at mm lang dito sa ating formula. Okay, next is yung kay B naman tayo. Palitan lang natin to ng 176.58 equals. So, si stress naman kay B is equivalent kay 69.6969 MPa. Okay. So, ito po yung hinahanap na value. na maximum shear stress at saka minimum shearing stress pagdating dun sa spring natin. Okay? Okay, so let's proceed to next problem tayo. Wait lang. Tignan ko lang yung mga estudyante na pinapa-comment ko. Okay, next problem po tayo. So, for the next comment, ang magko-comment po ay si Mr. Maduro, Mr. Bungaling, Espanyola, Miss Espanyola, at Mr. Vizca, no? So, the formula will be formula for polar moment of inertia of a circle, no? Polar moment of inertia of a circle. So, yun yung i-comment ninyong apat. Okay. Next tayo is next problem. Okay, so next problem, given the shear diagram of a beam as shown, so find the maximum negative moment of the beam, tapos find the maximum positive moment dun sa beam, and find the uniform load intensity in kilonewton per meter dun sa ating beam. Okay? Raise ko lang yung problem. Okay. Ano? So kapag pinag-uusapan natin si shear and moment diagram, kailangan lang natin itong intindihin kung paano siya ibabalik sa load diagram as well as yung pagkuha ng moment diagram. Kapag familiar ka sa shear and moment equation, madali lang din to, no? Pero ituturo ko siya pareho. Ituturo ko yung shear and moment diagram through area method and pagkuha naman ng equation ng value through the equation, no? So kapag tayo ay mag-solve solution number 6. So, kung itutuloy-tuloy natin to, pag ganito, to get the load moment diagram, tama bang kukunin mo lang yung area ng bawat bawat nito, para makakuha ka ng ilalagay mo na magnitude pagdating dun sa moment. Okay, so let's start with this value. So, kung titingnan mo, meron kang 20 and may 60 ka, so kapag nilagay natin, kukumpute natin yung area, yan ay trapezoid, tama? Meron kang 20 plus 60 divided by 2 times the height. The height will be 2 meters, no? So, meron kang 80. So, kapag ililipat mo siya sa diagram, so meron kang side face na 80 dito. Then, meron ka ulit dito sa taas, lagay mo lang, kunin mo lang yung area, so meron kang 80 plus 40 divided by 2 times 2. Nilagay ko pa, makakancel naman yung 2. Pero ilagay lang natin para makita ninyo. Equals 120. So, meron akong 120 na pataas. But yung 120 na pataas na yon is, ima-minus mo yung 80 dito. No? So, minus 80. So, meron kang 40 na inangat. So, kakaroon ka ng 80 dito. 40 pala. Meron kang 40. Then ito, 40 din to, magsi-zero yan. Okay? So the value na hinihingi dun sa ano natin is ito at ito for the first and second question. The maximum positive moment is this one, 40, and the maximum negative moment is this one, no? So same goes din dun sa equation. So para makuha mo yung equation, m max negative is equivalent kay the area lang nito. So, pwede natin sabihin 20 plus 60 divided by 2 times 2 equals 80 kilonewton meter. For the M max ng positive naman is equivalent kay the area nito. So, 80 plus 40 divided by 2 times 2 minus lang ng area nito. So, meron kang 80. Therefore, M max positive is equivalent kay 40 kilonewton meter. So, ganun lang yung proseso pagdating sa shear and moment diagram, area method, and ano tawag ito? Shear and moment equation, no? For the load diagram naman, so pwede mong kunin yung triangle nitong dito. So, for the load diagram, makukuha mo, di ba may 20 na pataas to, pababa to. So, ibig sabihin, kapag i-convert natin siya into load diagram, meron akong 20 na concentrated dito, plus itong nandito. So, ito ay magkakaroon ka ng 40 dito. Ito ay 40, tama? 40. Yung 40 na yan, i-divide mo lang yan dun sa di-divide mo lang yan dun sa length para makuha mo yung uniformly distributed load. So, 40 divided by 2, meron ka rate na 20 kilonewton per meter. Same goes with this one. So, meron ka ditong 40 ulit. Pag dinivide mo yan sa 2, meron ka ulit na 20 kilonewton per meter. Then ito, another 20 kilonewton. Then meron kang reaction dito at meron kang reaction dito. Okay? So, dito, for the equation, so ang sagot dyan is 20 kilonewton meter po yung sagot, no? Para dun sa ating pangatlong question. Pero kung magagamit ka po ng moment equation, ganun pa rin naman yung mangyayari. The area, yung length nito, divided by mo lang sa length. Yung height nito, divided by sa length, makuha mo yung value, no? So, madali lang naman yung shear moment diagram at alam ko lahat ng students ay marunong gumawa ng shear and moment diagram. No? Okay na. So, next proceed tayo sa problem number. Next problem tayo. Problem number 7. So, yun. I do hope na naiintindihan ninyo or kahit paano na-recall kayo kung paano siya isosolve. No? And I do hope na yung ibang mga estudyante na nanonood sa akin or umaabang ng aking video para sa kanilang review ay sana makatulong din po ako, no? And ayun pa rin. Para dun sa aking estudyante, lahat naman ata ay natawag para magbigay ng comment dun sa aking video, no? For another video, magsusunod ako ng panibagong video para sa mga susunod na subjects, no? Like yung statics of rigid body, dynamics, or reinforced concrete design, no? So, yun. Ingat po rin tayo, no? And hoping na magkaroon na ng face-to-face exam at face-to-face class din ngayong taon, no? So, ingat po tayo and please subscribe na lang din po ulit sa aking YouTube channel at pakiclick po yung notification button, no? Medyo busy kasi kaya hindi din ako masyado makapag-upload ng maraming video, no? Ng tuloy-tuloy. So, yun nga. Ingat lang po tayo, no?